Hey there, welcome to today's video on section 14.5. This will be our third to last video of the year. So here we're asked to write trigonometric functions and models. Basically what we're going to do is we're going to write sine and cosine equations from a graph. That's probably the easiest way of saying it. That's what we're going to do here. Before we do that, just so you know, these right here are the general ways you can write a sine or cosine graph. A is the amplitude. Period equals 2 pi divided by b. H is a horizontal shift. And K is the vertical shift. So let's keep all that stuff in mind when we're going through these problems. And the other thing I want to define is a sinusoid. A sinusoid is simply a graph that can be modeled as either a sine or a cosine equation. So very, very simple. And if you look at examples of sinusoids, like something like this here, that's a sinusoid. And we can write a sine function for that graph, as well as a cosine function. And you can label it any way you like 0, pi, pi over 2, 3 pi over 2, 2 pi. Like in this case, I would know this is y equals sine x, because that's the y equals sine x behaves. But it also can be expressed as y equals cosine x minus pi over 2. Because if you think about it, cosine is supposed to look like this. And if I were to trace a portion of this curve, it's almost like taking the cosine graph and shifting a pi over 2 to the right. So these are both the same thing. Let's look at a real example here so you get a better idea of how we can write cosine and sine functions for graphs. So in this case, you have to write a cosine and sine functions, sorry for the poor grammar, for the graph below. Now it's going to be a little bit hard to read. So let me tell you what this is. That's going to be pi over 2. That's pi. That's 3 pi over 2. Negative pi over 2. Negative pi. Negative 3 pi over 2. That's 1, 2, 3. And negative 1. So the first order of business is we'll try to write this like a sine graph. In this case, if we look for h and k, actually it might be easier to kind of reverse engineer this. Let's actually find the midline. So the midline is obviously at y equals 1. So what does that mean about k? Think about what would k equal. If you said 1, that's good. Amplitude is 2. That's a distance from the height or the peak to the midline. So A equals 2. And then the period it seems like the graph repeats itself. We can start it, say, over here. So period will be 2 pi. Since cycle can start at negative pi and end at positive pi. And remember, pi minus negative pi will equal 2 pi. So in this case, the period here is 2 pi. So B equals 1. Since 2 pi over B equals the period, and if you solve for B, you get B equals 1. Okay, so now let's work this out. We'll see for the sine curve, sine function, cosine function. So y equals a sine bx minus h plus k. Here y equals a cosine bx minus h plus k. So we know the amplitude is going to be 2. And for sine, let's say we started right here. If you start right here, the amplitude is going to be 2, and it's rising, so it's not going to be negative. Sine 1 x minus 0 plus 1. If you think about it, there's no horizontal shift. If I'm starting sine at this place right here, because sine's supposed to look like this, right? That's what we expect for sine. Let me actually try a different color here. Or actually highlight it. So we use turquoise. That's how sine's supposed to look. It's always supposed to start at the midline, go up, then down, then back up again. So it seems there's no horizontal shift. That's why I put h is 0. And b is 1, because we found that earlier. And a and k, we found this as well. So the answer is just going to be y equals, let's change that up. Y equals 2 sine x plus 1. Now for the cosine, so we probably could start, say, right here. Let me erase the turquoise. So say I start right here, start at the peak. So since I'm starting at the peak, our A will be positive. So 2 cosine, period is still 2 pi, so B will still be 1. X minus something, and of course plus 1, the midline is 1. But h will be different, because that's how cosine and sine are going to vary. And in this case, we see that it starts at pi over 2. Starts at pi over 2. So, and then of course if you draw on the curve will look like that. That would be your cosine, what I highlighted in yellow. So you put minus pi over 2. So y equals 2 cosine x minus pi over 2 plus 1. So you notice the only difference between these two is h. A can also differ if graph starts at a place where sine has to go down, or cosine is at its trough. For example, I could have said that this was my starting point for the cosine graph. In that case, a would have been -2. Or I could have said for the sine graph, that was my starting point right there. And, it would have to go down, then back up. So you could make a negative if you want to. So there's actually infinite answers for these. So there are infinite answers if no restrictions are placed on A or H. So let's try one more, and then I'll be done with the video. Okay, that was not supposed to be there. I don't know why it says graph y equals. I think I copy and paste from an old file. Let me cross that off. That's not supposed to be there. Okay. Interesting. Does not want me to cross it off. Let's try again. Alright, this is getting a bit frustrating. Anyway. That's what I'm trying to do there. Okay. So what we want to do is we want to write cosine and sine equations for the graph below. Okay. Again, let me label this, because it's a little hard to read. Pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. 1, 2, 3, and -1. So, midline, y equals 0, so k equals 0. Amplitude is 1, so a equals 1. Period. So the period is pi. So b equals 2. Because remember, 2 pi over b equals the period. Okay. So if I write a sine function for this, y will equal, now let's look at the pink. Notice how it goes down then up. So I could say -1 times sine of 2 parentheses x minus 0 plus 0. So y equals negative sine 2x. If you want to start right here for the sine function. I also could have started right here too. If I start right there instead, and do this, then I could have said y equals 1 times sine 2x, now minus negative pi over 2 plus 0. So we sine 2x plus pi over 2. That also would work too. So there's actually several answers you could say. So A could be positive or negative. So I should be careful when I say so A equals 1, or it could be negative 1, depending on where you start with H. Let's look at cosine, then we'll be all done with this video. So y equals, now let's say I want to start my cosine. Let's highlight this with yellow. Let's say I want to make that my cosine. Now if you think about it, if that's at negative pi over 2, then that would have to be at negative pi over 4. So, given that it's starting at negative pi over 4, and it's starting at its peak, we could say the following. 1 times cosine. I'm on the video right now. I have to go back. So y equals 1 times cosine of the period's the period's pi, so b is 2 x minus negative pi over 4 plus 0. So in this case, it will be a cosine of 2x plus pi over 4, and that would get you your answer for that one. Or you could have started at the bottom that's another possibility. We could start here and did that. So this case is starting at pi over 4. So we also could have said y equals negative 1 times cosine 2 x minus pi over 4 plus 0. So you could also have negative cosine 2 x minus pi over 4. So that could have been another answer you could have had as well for this. So there's not just one way you could write these equations. So let me pose a question here. You might want to copy this down. And then I'm going to ask you to answer this on the Google Docs form. But here's what I'd like you to do. Say we had a graph like this. Yeah, these points right here. So you have like 1/2 comma 1 and 3/2 comma negative 3. So on the Google Docs form, write a sine and cosine functions for this graph. So that'll be part of the Google Docs form. Knowing those points, I think you can handle it, and we'll see what answers you get when you finish it. Alright, so we're all set, and I will see you guys during block 1 of this week.